Alright folks, so I am here starting my mod video for the Blazin Bow. I've had this bow for less than 24 hours and just finished recording my Aerostorm review video, and the reason I used the Blazin Bow for comparison in there, one, because it did seem relevant using one of the oldest and one of the newest arrow launching blasters, but also because I was planning to modify this immediately. And so I have opened up the Blazin Bow, and I discovered the simplest internals of any Nerf blaster that I've ever seen, aside from possibly a blowgun, some sort of blowgun. So, taking a look in here, there is no catch mechanism. That's certainly what this looks like, but this is just a spring rest. And so then here's the spring, and here's the plunger, pull handle, plunger head is at the end of this rod, and then here's the part that the arrow rests on, of course. So then I lift this out, and we take the plunger rod out. Yep, take the plunger off, and here you can see here's the pull, spring rest, the spring, and the plunger rod. Now there isn't an O-ring on here. This isn't a standard head with an O-ring. This is a soft rubber head, and I think this is designed to give it a better seal over the course of the plunger rod the plunger tube narrowing from the back to the front. It has a draft. It's larger at the back, tighter at the front. So this, as it goes along, will deform, giving it a fairly nice seal. Additionally, this soft rubber gives it a little bit of padding. I don't know how I feel about this. I wish this was a standard plunger head. That's for sure, because it'd be easier to tell how good the seal is and to improve it if necessary. The spring slides freely here, and unlike the Fire Strike I just finished modding, the plunger rod is in two pieces. The handle portion at the back and the actual plunger head and rod up at the front. I'll be able to take the screw out and pull the spring off and do spring additions very easily without any damage to the blaster, which is very nice. Then, of course, we've got the plunger tube and the portion that the arrow rests on. The plunger tube is just a tube with a large air release hole. I'm going to pull that off. And the most complicated part of this entire blaster is the air restrictor, which falls out just like that. And there we have an air restrictor removal, and here you can see the rear spring rest and also the portion that the plunger rod makes contact with, the spring, and this long stick here, this large disc would reduce airflow. Then you've got the portion up at the front that the arrow pushes down. So we've got that, and like I said, that disc definitely reduced airflow. So, in fact, that might even be the part that actually sealed it, but I really don't care too much because that's gone. So, the other thing is, here's this air release hole. I don't know how I feel about that. Now, the thing is, okay, you have to really think carefully when you're making modifications, usually, because you don't just want to change something without knowing what it does. If you haven't modified a Centurion and you want evidence of that axiom, that theorem, go take a look at a Centurion, because when you're modifying a Centurion, there are parts that look like standard function locks, which we all know can usually be removed. I'm trying to put this back in as I speak, so pardon me. But the thing, here, I'm going to set it down. The Centurion has a bunch of parts that look like standard function locks that you can just pull out. Normally, they don't really need them there. You don't really need them there. And then I learned that those were critical to the function of the blaster, period. It wouldn't function at all without them. So you really need to do your research before you start making modifications to something, and that's definitely a big part of engineering. You need to think things through. So, here is all this. I'm trying to see here. I don't think that extended the draw. any, but I'm trying to look. I'm going to set this back down. I'm sorry about all the camera motion there. Yeah, the plunger rod doesn't really have much to contact, except, well, the inside of this piece here. Does it? It's limited in its forward motion by the handle back here. It won't go any further forward. So that means there's a crap ton of dead space in here, which is good for the coupler, for the plan I have for putting a coupler in here. Now the thing with this air release hole is, yes, that will reduce airflow as the plunger head goes forward. There will be some venting there, and everyone knows essentially the only part of this that is really used is forward of that air hole. It's the forward part of a plunger tube in general. Well, I could plug that easily with tape, and that would probably increase airflow, compression as it goes forward a little bit. But the problem with that is, okay, as the plunger rod moves forward, if this was a totally sealed system, there was no way for air to travel into the back of this plunger tube. If that was the case, then you would, as the plunger tube moved forward, if you had a good seal, there would be some suction being created here, some negative pressure as the volume inside the plunger tube behind the plunger rod increased. It would be hard for air to get to that, and that would slow the plunger rod slightly. Well, there's plenty of air, room for air to travel into the back of the rod, of the tube. But the problem is, if I cover this up and I get a really good air seal, and I have a dart in here, or an arrow, the problem is, air isn't going to have a very good way to get into this plunger tube without that hole. So if I plug it, I'll use my finger. This isn't a very good example because the front is open, but I hope you understand what I'm saying when I don't know if I want to plug this hole or not because I put my thumb there, and if I sealed everything else up, all of a sudden we could generate some negative pressure. We certainly won't generate in front of the plunger rod as much air pressure as we'd like because it'll be sort of a vacuum. I hope you understand that. If not, I can't do much about it. I've got the bow apart. I am still incredibly just impressed and quite happy with the simplicity of this blaster's parts because, I've got the pieces all in this area here, and I'm not worried about losing a single one of them. Goodness, it is so simple, and I don't have to worry about figuring out how to put them back together. I am going to go with a universal coupler. That means I've got a 1/2-inch PVC and 1/2-inch CPVC couplers, and each of these takes a different size of PVC tubing. And the thing is, this one's smaller and this one's bigger, of course. And while I'm planning to use just a standard PVC pipe in order to connect the various attachments for this blaster, I don't know if I might come up with one that needs a CPVC coupler. And how you do that? You just stick one inside the other, and you're good to go. Now, of course, you want to take that sticker off, and there's this little nub, if I can, oh goodness. Here, I'll pull out this other one. There's this little nub here on the side of the CPVC coupler, and you need to grind that down, and that you won't be able to see it too clearly. You might be able to right there in the middle. The CPVC coupler can't reach the midway point of the PVC coupler because that little nub is in the way. So you grind it down, and you can see how much farther in it goes. And that just reduces dead space just a little bit more, and I like that. It's also a bit more of a solid connection. So what I'm going to do is sand down the contact surfaces of these pieces, clean them off with alcohol, and use my plastic repair epoxy, which is also good for PVC and the like, and put these together, and I've got my coupler ready to go. The next thing I'm going to do is take this piece. I need to save this barrel, so I'm going to take a bandsaw and cut it off right here, and then I need to figure out how to integrate this part and this part. Also, you can see I've got my shell, the other half of my shell over here. Now, a perfectly legitimate way to save your screws if you're not planning to do any painting later is to just leave them in their holes and cover it with masking tape. I don't encourage you to leave it there without tape because if you bump it, if you move it around, the screws will fall out. And the reason you'd want to leave them in like this is because you can take the screws out and they can be different lengths. And if you don't remember exactly where they all go, you can put a long one into a short hole, which can cause stress in the shell. It might stick out the other side. Happened to me. Or it cannot secure the shell properly by putting a short screw into one that should be long. So this is a perfectly legitimate way to save your screws. And here you can see I've got this barrel cut very cleanly off from this piece. I cut it as close as I could. And I am saving this because this will be attached to a piece of PVC to become an attachment, allowing this blaster to still allowing this blaster to fire its arrows. And I am going to ream this out so that I can connect this coupler in place of this barrel right on here. Alright folks, so as I mentioned, I cut off the barrel here from this piece. Then I took my CPVC coupler and sanded all the way around. Then I took my PVC coupler and on the inside of just one half sanded, because all of this is going to be epoxied together. See, this is going to go like that. And then I took my spherical grinding sanding bit here for my Dremel and got in there and sanded up everything in front of this line. Because behind that, that's just where the breech tube or the plunger tube sits. In front of that, and most of the stuff you see in here is just plastic dust that I haven't cleaned out yet, but everything kind of around these flanges, the plunger head actually stops at the flanges, so that's all dead space that's going to be filled. And when I turn this over like this, and since I reamed this out to just the right size, you can see I'll just be able to fill this with epoxy putty to hold it together and fill in the dead space, and this will be a solid, very clean integration. Additionally, I dug through my spring parts bin, and found this long strike spring that hasn't had much of a use at all. Now, I was going to go to Ace and Home Depot looking for outright replacement springs. Maybe a K26 will work. I don't know. I've never picked up a K26 or 25. But I found that with a little work, these could be nested together. They both fit within the spring rest, and they're both about an appropriate length. So, a stock spring plus long strike spring, that ought to be plenty powerful. I can always up the spring strength if I need to later on. Now, I recommend if you're testing out springs, be sure you put this screw back in, and it has to go in all the way for the spring to compress and not catch on it. Be sure you put this screw in, because if you test this with just putting these the front and back of the plunger rod together, as the spring compresses at some point, the friction fit will give out without the screw to hold it, and the front half will just fly off and fling forward, and you don't want to risk the damage. As you can see, I've got my blaster piece, my two couplers, my plastic epoxy, my plumbing plastic epoxy putty. I'm going to assemble all these together in the manner that I showed you in the previous segments, and I'll show you the final product. I have the coupler piece here curing, and you can see I just weighted it down with this book that I balanced on a coffee cup, trying to put pressure on it, and let this epoxy sit really well. The next reinforcements I'm doing involve a small amount of epoxy putty in this little channel here, just to back up the screw that's holding this holds the plunger rod together, as well as either some metal or epoxy putty reinforcements to this thing that makes me think of a catch, and I want to call it a catch desperately, but it is in fact just the spring rest, and that sits in right here. And additionally, even though I don't think the springs I've got warrant it, in case I do ever drop in a super powerful spring, I'm going to put epoxy putty reinforcements in the shell here and here behind that rest. Hey folks, so I just made my first mistake. You can see here I put in my epoxy putty reinforcements around the, well, it's not the thing that holds the catch, it's the walls that hold the spring rest. Well, I mixed a little more putty than I needed, so I just put it all in here, hence all its excess. And I thought that this piece here, this plastic piece, there's a couple of them around the shell, slotted outside of this one up here. I thought this would slot inside of this one. I was completely wrong. So now I've got all this putty built up, preventing this piece from sliding over this one. So you might be able to make out, there's already a little bit of a cut mark there. I took my Dremel, put on a sanding mask, mind you, because this stuff has some potent fumes, and as a dust it is very, very bad for your lungs. Most epoxy and epoxy putties are, but I'm not going to be able to sand that down cleanly or easily. So what I'm going to do is I'm just going to take my Dremel and cut out this piece here. I don't think it is super important structurally. I'd rather not do that, but now I know this for the future, and you've been warned. Make sure you, when you put your epoxy putty in anything, that your blaster can still go together. You can see that when it comes to these little, whatever they are, support slot post things, I entirely removed this top one, and then I ground down the forward portion of this one here. And that allows them to fit around the extra epoxy putty I've got down here and up here. And the shell goes together just fine, and I don't think structurally it is compromised at all. Now, in order to make room for this larger coupler piece here, what I've done is I stuck this against the muzzle on the shell, and you can see I traced it with dry erase marker, and this isn't an absolute, this is just a guideline. Once I get close to that line with my grinding and sanding bits, I'll be able to test fit. So test, sand a little bit off, test again, sand a little bit more off, make it a nice perfect fit, and since this is dry erase, I should be able to use rubbing alcohol to remove all evidence of this marker completely. Alright folks, so I showed you how I trimmed away this part here to allow this coupler to fit. Something I'll point out, in case you want to use, you're not planning to paint this, turns out a dry erase marker does not clean off of PVC or paint particularly well, which doesn't bother me too much because at some point I was planning to paint this orange anyway, and I might as well retouch that up. So you can see I filled the dead space here with epoxy putty. Hot glue certainly would work, but I wanted as many strong chemical bonds between the couplers and this plunger tube cap as possible. You've already seen that reinforcement. You've already seen the pieces that I had to grind away. I'm trying to just summarize everything I've done so far. Here you can see where I added some epoxy putty to the back of this, right in this little space here. That side has no room for anything, but over here I added this just to reinforce the screw post as much as possible. Make sure that it's flush. I doubt that this will make a whole lot of difference, but it satisfies my need to reinforce things as much as possible, and it might provide a little tiny amount of almost immeasurable support, but I made sure that I did that. And I don't think there's anything else to show you really except the fact that this spring rest, it's not actually a catch, though it really makes me want to call it a catch. This spring rest, I am going to use my sheet metal to create a reinforcement that will just sit in here. I might epoxy it in, we'll see. And I will show you that in the next segment. So I've got my sheet metal from Home Depot that I use for bolt sleds and similar reinforcements. I took my spring rest, I placed it on the corner, and I couldn't find a scratch-all. So and I want something more precise than a marker. So without a scratch-all, I decided to just use the tip of my utility knife, traced the edges. It's kind of tough to see, but I think you get the gist of it. What I'm going to do is use my tin snips to cut away the edges. First I'm going to cut it out, then I'm going to take that piece, trim off all the edges, plus a little farther in than these lines indicate, because it needs to fit inside these raised walls here, and I marked up the outside. So I'm going to trim away just a little more than I think I should. I'm probably going to have to Dremel out the hole in the middle, and then I'm going to stick this into a vise, table vise in the shop to flatten it out, and then I should be able to drop this right in here. Quickly, before I get started, I want to show you that I used a pencil, stuck this raised edges up, used a pencil to trace the circle, and that'll work just fine. And I want to remind all of you, when using tin snips, any tool really, but particularly tin snips here with this metal, even though it isn't a powered rotary tool, please, for the love of God, wear your safety glasses. This stuff flies all over the place. I was having a real hard time getting this piece out of the middle, using different tools, grinders, knives, just having a real hard time. So what I did is I took this chisel-like punch, and I stuck it on the side, tapped it down gently with a rubber mallet, and I went all the way around and got the piece out. So I'm going to use a circular or conical grinding bit to smooth out these edges after I go put this in a table vise to flatten it out. In order to make this inner hole smooth and large enough for my plunger rod, both halves need to fit through here, seam just perfectly. What I've done is I stuck it in there. What I do is I hold both pieces and I stick in my grinding bit, and you can see it's got quite a bit of aluminum dust caked into it now. And I hold it on one side. My phone rang. I hold it on one side, and I put the grinding bit and I try to smooth out and expand the other. Now I will warn you, because this is metal, it will heat up very quickly. So you want to do as much as you can. It'll start to warm up, and then you just set it down. And the nice thing about metal is it has a low specific heat, low specific temperature, so it will heat up very quickly, but then it will likewise cool off very quickly in a matter of seconds, and you'll be able to go about continuing your work. So I highly recommend you smooth this out as much as possible until your plunger rod will fit through it absolutely flawlessly, and it will move easily. Then you want to scuff up the inner surface of this a little bit, as well as the side of this that you'll be attaching. Clean them off with rubbing alcohol, let that dry, and then epoxy it in place. In this case, less is more, and take some rubbing alcohol on a cotton pad. Will come apart. I need to find something better, but take some rubbing alcohol with something and clean off the excess on the inside of this circle for certainty immediately before it even starts to cure at all. And then let that sit, let that cure.